I think we stopped here. We were looking at some projected impacts on various species of animals, and there's a nice book called The Sixth Extinction, which talks a lot about. There have been 5 mass extinctions before. This one talks about how we are in the middle of the 6th one. This is just continuing that. Not that many ocean simulations have been done for ecosystems in any of the IPCC scenarios. There's not that many models, but hopefully this time AR6 will have many more simulations. Nonetheless, there are 2 or 3 that put out messages like this, looking at various species like mollusks and crustaceans, cold water corals, warm water corals, and so on. There's also lots of data on fisheries, but that's mostly on how fishing pressures have impacted the total catch and so on. Obviously, the news is not very good. There are lots of studies done on the changes in crop yields. The complexity of the models varies. Some are just temperature-based crop yield relations, for example.
In the above figure, what is the control?
So it is basically something like a pre-industrial CO2, the run made for a long time. All IPCC scenarios actually start from pre-industrial. They make a long simulation to create a baseline, and then they run forward with various levels of CO2s.
And the numbers at the top of all of these columns?
These are the number of scenarios that were done. I think this is not the number of models, but the number of...
Not the number of species.
Shouldn't be. So this is positive effect, no effect, negative. Sorry?
If it is the number of species, then control has 140 and others are 16, 15.
Well, control is 40, not 140, but... yeah, I'll dig up the caption, which I didn't include here, but this is in the document that is given as the summary. It should be in there. If it's not in there, let me know. It may not be actually in there. But the main point I want to make is that the models that are run for ocean ecosystems are very, very few. And in fact, none of the models actually model explicitly the corals. You are only modeling the temperature and salinity dependence of corals, and based on the carbon level, you are going to translate that into the precipitation change and temperature change, and then empirically say how many corals are going to be affected. I'm a bit nervous about all these things because the data is not very good for these, and this has become a problem in the sense that some of the corals are actually doing better in some regions, whether it's against acidification or against warming, and we are not completely sure why that is. Okay, so just keep that in mind. Take that with a pinch of salt, as they say. But this is there is much more data, historic data of how crop yields have changed, and we have decent models that do either individual crops or functional types. There is various ways of doing ecosystem models. For example, none of the models really explicitly would resolve mollusks, but they do what are called functional groups. So what do mollusks do? What do crustaceans do? And so you put all of them kind of together and give them the functional information, and then those are dependent on oxygen, temperature, salinity, and various other things, light, etc. So it's a bit complicated. This is much better constrained. So this is showing some crops which will have increased yields over time, some will have decreased yields. And the main point, again, going from here is that in the more near future, we don't expect big changes. So the number of crops having increased yields is almost the same as the number of crops having decreased yields. But as we go into the future and the warming increases, the warming gets stronger, we are obviously going to have many thresholds crossing, plus you also have other impacts of changes in the growing length, season of the growing length, or growing season length, whatever it is. And you are also going to have changes in nighttime minimum temperatures, daytime maximum temperatures, and so on. And the net effect will be that there are very few crops which will actually respond positively, and almost all other crops will respond negatively in terms of crop yields. The solution-wise, if you are somebody who is going to worry about solutions instead of just the bad news, then if there are corals which are responding with no effect or positive effect, then you may want to understand what is the genetic material in those corals that is helping them survive better or be more resilient. And maybe you can mix them with the other corals which are not doing so well. This is not very science fiction or anything, because with crops, already there are ways of mixing. So there are various jowar species which do much better in drier, warmer climates, and there are some that need much more water. And people mix them. So you can go to this agricultural university, which is somewhere nearby, I don't know how far it is, and they are doing these kinds of works already. So it's not so hard to imagine that these kind of techniques will be applied in the coming future, and people are already working on those kinds of ideas, not for corals, but for crops, yeah.
This is under which scenario?
This is again from the summary report. You will see that this is just taking the old. I think this is from AR4 actually, not from AR5. But let's look at it during the question period. I will bring it up. There are various number of, I don't think the crop yields was done for all the scenarios. It was done for only 4 maybe, but we can look it up. But again, I wouldn't go, RCPs, and they give guidance in terms of global governance. So the issues have to be basically split into what will be part of the global negotiation. So carbon trajectories are part of the global negotiation because CO2 is going to increase the same amount everywhere, right? All the other impacts are going to be local. Okay, crop yields, it's not going to be the same, like this is not saying which latitude, which longitude, nothing, right? It's how the precipitation, this is a net effect of crop yield change. So keep the RCPs in mind, but don't try to make it very rigid about which RCP will give this kind of result and which RCP will give a different kind of result. Because if you are reaching RCP 8.5, you're going to be having very serious issues of just human health, for example, or water resources, and so on and so forth. So when you look at the executive summary, try to see how the choices are made. Okay, so here also, it doesn't say necessarily which RCP, just gives you carbon levels, right? Because RCPs involve so many assumptions about technologies, population growth, and so on. They are kind of, so if you have to control carbon, the population issue was not even discussed before AR4. There was a lot of religious opposition, and people thought IPCC should not touch this issue. But I will show some figures which actually, from my perspective, it's a completely bogus issue. The population and climate change are being kind of totally misrepresented in the way they should work. So take these things as kind of guidelines, right? Because if by 2029 or 2050, what is the best horizon? If you are a prime minister or even the UN General Secretary General, what time horizon would you worry about? I would not go beyond about 2030 for most things. Okay, some other things like building a big port or energy infrastructure, I would worry maybe till 2050, because you make hard infrastructure investments. For example, if there is an active port in India and it is now able to handle certain size of ships, and if sea level rises, what happens? So you have to invest a lot in those things. But those are long-term investments. That's not a 10-year investment. So you have to choose which one you're going to invest in. But those are all kind of complicated issue in terms of who's going to make what decision. So when you look at the executive summary, just try to get a sense of the range of issues they have to worry about. So ocean, we are not even modeling these things explicitly. As I said, I've been involved in developing ocean ecosystem models. We just do large phytoplankton, small phytoplankton, large zooplankton, small zoo, nitrogen fixers, and so on and so forth. We don't know how to model all these other things. So it's a complicated issue. But using whatever knowledge you have to project for the future. The other big thing about dealing with climate change is these two concepts called adaptation and mitigation. I think we already mentioned adaptation in one of the slides, which was basically, again, before about AR4, this was not used at all because they thought this means we are saying climate change is unavoidable. But now climate change already has happened, so obviously it's unavoidable. So now we are talking about adaptation. So the few things that show up, there are lots of them, there's a very long list. Change in land use and relocation. Relocation, as I said, Vanuatu has already planned. It plans to move all its population to another island once sea level gets beyond a certain level. Okay, there are many complicated issues. For example, everybody knows what exclusive economic zone is, right? Anybody heard this before? Each country from the coastline has a 200-mile limit, which is its exclusive economic zone. This only started a few decades ago after US declared that anywhere you have a coast, 200 miles is exclusively yours. Nobody can just come in there. It's not international waters. So if sea level rises, and if you have an island that is this big and then sea level reduces to this size, the exclusive economic zone which was here before, does it reduce or does it remain the same? No, it's not a scientific question. It is a legal and philosophical question. So the question to be decided is whether their exclusive economic zone should shrink or it should remain the same. Okay, so legal arguments are being made to say that even with coastal erosion, your exclusive economic zone doesn't keep shrinking. So sea level rise shouldn't shrink it, right? You have the shelf area and so on and so forth. So those are complicated issues. But change in land use means basically how you do agriculture, how you do deforestation, how you do urbanization. Relocation is basically if you decide Bangladesh has serious sea level problem, can you force people to move? This is obviously very differently handled in the US. US development companies are very rich, very strong. Actually, even in India, they are now. So when you are building, whether it's a coastal highway or you are trying to build something very close to the coastline, you have to worry about what are the projections. Then can you ban people from settling very close to water and so on and so forth. Emergency and business continuity planning, this again is about infrastructures, how extreme events may change certain things in Bengaluru, let's say, in terms of drainage, in terms of where it's going to be very hard, like some lakes are getting polluted and catching fire and so on. Upgrades and hardenings of buildings and infrastructure, this is a big thing where for a long time, there has been building codes for earthquake resilience, for example, which is very important in California and in Japan and so on. But now you have to start worrying about building codes and infrastructure in India, where something like Uttarakhand flood, which happened, I don't know, in 2010 maybe, obviously there was a cloudburst and rain. But the landslide was basically man-made. They built very unsafely on slopes, and that kind of rain should not have crashed so many houses. So that has to change. So this is how it will be implemented. It's not clear, but you can easily sit down, look at the projected climate changes, and you can begin to say these places are going to be unsafe, and so on and so forth. Residential programs promoting adaptation. So this is about, this goes in many directions. Actually, now it's very common to have what are called mixed use neighborhoods. So you try to build places where everybody is going to reduce their driving or commuting by a lot. So you have office space, residential space, market space, schools, playground, everything arranged in a way that you travel as little as possible. So the smart city ideas, for example, have to include architectural plans which promote adaptation, which obviously also intersects with mitigation. Mitigation obviously is where you are trying to reduce the emissions themselves. You are trying to reduce climate change, right? So you do things like energy conservation and efficiency, renewable energy, sustainable transportation, and so on, carbon sinks. And there is intersections where ceiling buildings will reduce energy loss. So every time you see somebody waiting for an elevator, even though it's just one floor and you are young enough to walk up, or on escalators in movie theaters and malls, young people just stand up, get on the escalator and stand as if it's some amusement park ride or something, right? You're young enough, you can walk your ass up the steps. It's a convenience, it's not an amusement park, right? And every time you open and close the door of buildings which have AC and so on, you can count how much energy loss happens. That's why they have rotating doors and so on, which reduce the loss much more. So all these kinds of things have to be taken into account because those are small things, but if you imagine a city like Bengaluru, which has so many buildings, if you save few watts per day everywhere, every building, then you can scale it up to India and the world. There is tremendous amount of energy being used and lost. So green infrastructure is about combining drainage. There are permeable pavers, rain gardens, storage ponds, rainwater harvesting. This campus may have been done that way, I'm not quite sure. I think it is tried to be green and reduce runoff and reduce nutrient loading, even though they have too much lawn for some reason. Lawns are like aliens controlling human beings. They are worthless, but we are spending so much time, energy, water on lawns, right? It looks good, maybe, but you cannot walk on it. So what good is it? You cannot sit on it, cannot smoke it. So what's the use? So water, energy conservation, very straightforward one. Smart growth, this is again similar to these where growth is done, but you can reduce the impact on water, energy, food production, water quality, air quality, and so on and so forth. So if you think about that word, growth is used very loosely, but Herman Daly is an economist from University of Maryland who has been writing for a long time on growth versus development. If you think about the way things are built now, everybody has a smartphone, but everybody has a different smartphone. Each one has a different kind of charger. So basically you buy a new phone every year or 2 years, depending on how rich you are or how much your parents are spoiling you or how much you are earning and so on. So we are producing so much junk, right? When did this philosophy of making things completely obsolete in a very short time start? Only started after Second World War. A guy called Victor Lebo, which you would never hear of. He was just a retail salesman. And he wrote a little paper in some obscure journal saying that only way to grow economies constantly is to build things that will not last very long. So people will have to keep on buying again and again. Great idea, right? It works perfectly just as he imagined. Now everything is built to last very short time, and people don't hesitate to replace the old model with the new model. And we don't know what happens to the old model, right? It gets junked somewhere. Some poor Chinese people sit and take out the gold or whatever is in there. But that health impacts of that is now known to be quite horrible. I think India is also now importing some electronic junk and recycling them. So the amount of irreversible conversion of natural resources into junk is very high. So smart growth or economic development versus economic growth is supposed to kind of avoid those kinds of traps. But we are obviously a very long way to go from becoming much less wasteful, right? So we looked at a similar plot before, which was about the changes that have already happened in the physical system, ecosystems, biological systems, and human managed systems. This is the same one, but now it's looking at risks and vulnerabilities, including these striped regions, which show the potential for reducing the risk or vulnerability using mitigation and adaptation. Okay, so I won't go into the details. This is again just to give you an idea of how much detail goes into preparing these IPCC reports. So these are regional risks and potential for risk reduction. So you can see that polar, Arctic, and Antarctic systems are already at very high risk, and these are various scenarios which are not being, it should be in the caption somewhere. Yeah, so here it is, risk level, present, near term, long term with 2 degrees C warming, and long term with 4 degrees C warming. So here is the risk level with high adaptation, and this is the risk level with the current level of adaptation. So we are doing some adaptation, but if we can ramp up the adaptation, then we can further reduce the risks. So obviously you expect that the basic level of risk goes up even with adaptation. As the warming goes up, the risk goes up. And in the Arctic and Antarctic, right now, we don't even know what kind of adaptation we can do for protecting the biological species that are there. Risks for health and well-being, there are some potentials. Unprecedented challenges, especially from rate of change. So if the rate of change gets rapid, then the chance for adaptation to reduce risks also becomes less, and so on. So this is for North America, this is for Europe, this is for Asia. And now the idea is that if India wants to use this information, it has to take this and then somehow downscale it or make it more specific for its own region. Okay, so one of the things you have to remember is if India wants to do it, then it has to constantly worry about the vulnerability of its neighbors also. Because anything that goes wrong in your neighborhood, especially Nepal, Bangladesh, and Pakistan, which are quite poor, Sri Lanka is much better off, then all their problems are going to be your problems. India's economic growth is always going to be affected by what happens in the neighborhood. Coastal islands, obviously at much higher, and there are people like Emitters focusing just on Bangladesh, just on agriculture. So you can do it for each site. It is broadly doing as terrestrial ecosystems, wildfires, and marine ecosystems. But there are good papers on just vulnerability of Indian agriculture, for example. So you can do that sector-wise as well. These calculations of vulnerabilities are a very nice combination of social science and physical science, or what you call natural science. So in the general terminology, people also call natural science as the hard science and social science as the soft science. But if you think about this kind of information, the softest information is now coming from the hard sciences, but all climate change is actually just social science. Whatever the impacts, you have to deal with it on the ground with politics and social science. So the hardest decisions will be made by the softest sciences, right? So something that you have to kind of remember. There are many other tools evolving under the UNFCCC or United Nations Framework Convention on Climate Change. Something called loss and damage evolved around this time in 2011 when Typhoon Haiyan got, I think at the time it was the strongest typhoon ever recorded in instrumental history. Okay, so this region in the West Pacific is warming quite rapidly, and so anything that happens here can very quickly grow, a lot of evaporation, a lot of moisture loading, a lot of condensation, a lot of heat. So it became a poster child for climate change impacts on extreme events. And loss and damage basically means if Typhoon Haiyan got stronger than it would in a natural climate, which is called counterfactual climate. So this is the actual climate where you have global warming already happening. And counterfactual climate basically is an ideal climate where things remained at the pre-industrial level of CO2 and temperature and so on. So that every time you do attribution, you are checking things against counterfactual climate. So if in the actual climate, the typhoon got stronger than in the counterfactual climate, and the damage obviously happened is beyond what would have happened, then who compensates Philippines for this additional damage? There was a discussion on loss and damage, which would then attribute to the additional damage to climate change and then try to pay for it. They created what is called a green fund, which is supposed to have $100 billion per year. Such a fund got created, but the money that is put in is being used by the countries that put in instead of going to poor countries. So obviously nothing will work as easily as you would think. But what will happen is that people will begin to realize that even if you are sitting far away from the Philippines, you are not immune to the impact of climate in the Philippines. We mentioned terrorism as one thing, but this is a calculation of the Typhoon Haiyan. The direct impact, so Philippine exports such as coconut fell after Typhoon Haiyan, obviously. 6% of US all production relies on supplies from the Philippines. So there was a direct impact on the GDP because of the impact on Philippines. And 21% of US production could suffer indirectly from supply chain problems. And these impacts, you can see there is a large impact on which country would this be? Argentina, there are countries here. So a lot of countries depend on, and even in India indirectly depends on Philippines, so there are secondary impacts. So this will become more and more obvious that when you have severe damage somewhere, you will not be completely immune. You will suffer somehow or the other through the supply chain. So the global economy is good. Some would argue that Third World War is not happening because of globalization of economics. Otherwise, obviously, there would have been another war by now, the big world war by now. Is that a good thing or a bad thing? That's something you have to decide. So this kind of phase diagrams are made where you look at the cost of adaptation. So if you want to adapt to high sea level rise or increased storms and so on, you have to obviously build infrastructure to protect against those kinds of things. And the cost of impacts, whatever happens because of climate event, and the cost of mitigation. So here, if you do nothing, obviously the cost of adaptation will be low and impacts will be very high, right? As you do more and more adaptation, the cost will keep increasing, but you are not doing any mitigation, so you are not paying much for mitigation. But as you increase the cost, increase the mitigation actions like adopting more electric vehicles, more energy efficient dryers, air conditioners, whatever, you will increase the cost of mitigation, but you will decrease the cost of impacts. So what do you do with it? You can obviously make a complete portfolio of India to see where adaptation makes the most sense. Let's say a state like Odisha, which is not contributing a lot to the emissions. It's a poorer state. But it's getting hit more often by cyclones than any other state. Then you can do more adaptation in Odisha, whereas in a state like Maharashtra or Karnataka, which are richer and emitting like crazy, you can do much more adaptation by improving transportation, making the roads better, whatever else, and so on. So there are ways to use it, but that is enormous amount of calculation you would have to do. This is another detailed table that I won't go through, but this is now looking at issues and prospects for adaptation, and then there is a similar one for mitigation. Again, you have started with climate change projections, you started with climate models, RCPs, and so on. Now you're using all that information with social sciences to do these kinds of detailed calculations. So working groups, two focused on adaptation, mitigation kind of things. So the rate of warming trend, extreme temperatures, drying, and so on. So you look at all the climate drivers that would have to be considered under adaptation issues, and again, risk with high adaptation and risk with current adaptation. So if you don't improve your adaptation, the risk is going to be much higher, but there is a potential to reduce the risk if you do proper adaptation. Again, looking at the present, near term, and long term with 2 and 4 degree warming. And you look at various risks. This is the reduction in terrestrial carbon sink. So that is basically how would you reforest the world. There is a recent article many of you may have seen where it says plant 1 trillion trees to reduce carbon back to the original level. This is boreal tipping point, Arctic ecosystems, and so on. And you can see, as we saw before, there is not really much potential for adaptation in those high latitudes. It's open system. We don't know what adaptation we can do. It will be part of the global mitigation rather than adaptation. Amazon tipping point, most Amazon forests could change abruptly. So people actually do these bifurcation type of models to see if it has been done for India as well. If India keeps deforesting, whether the monsoon will collapse at some point, and so on. So you can see again here, this has got medium confidence, and this has very low confidence. So you have to also track. Somebody was asking about uncertainties. This is how you would provide uncertainties in these risks. You can say that Amazon is very vulnerable and it can abruptly collapse and so on, but the confidence in that projection is rather low. Okay. Of course, it goes to then how would you incentivize Brazil from deforesting the Amazon and so on and so forth. These are other things, displacements associated with extreme events, violent conflicts. So this is a very active area of research where people can attribute to several conflicts to climate stressors, what are called climate stressors, declining productivity and increasing morbidity. This is a very serious issue and this has already been quantified. You can take the temperature change and extreme events. For example, Europe got hit with a very heavy, very hot heat wave, I think 2 weeks last week. This week, US is, or this weekend, or next few days, US is getting hit with a massive heat wave that is record breaking. And you think maybe Europe is very safe against heat waves. In 2003, I think, when the heat wave hit, they lost something like 40,000 people died actually. So not everybody is as safe against climate extremes as they imagine. And there are details, if you look at the maps of who dies, it's older people, but also poorer people, women, and so on and so forth, okay? So in India, for example, it's in Europe and US, maybe you can provide a warning and say, don't go outside, turn on your AC or something. But in villages in India, what are you going to do? There's not much you can do. You will just sit there and wait. In fact, it's well known if you go to some regions in Tamil Nadu, older people, if it is a drought by June, if it doesn't rain, many old people say, okay, this will be my last summer, because they know that it will get hot and they probably will die this summer, because if it doesn't rain in June, it's not probably going to, it's going to rain much less this year, and so on and so forth. So those kinds of things are included in the morbidity and so on. This is the reduced access to water for urban and rural people, and you can see at very high warming rates, the change in risk by adaptation also becomes less. Okay, this is the other part of it, the mitigation costs. Again, comparing against baseline from 2010, the baseline by 2030, the cost will still be low. This is what is becoming more and more clear now in the messages from IPCC, that if we don't do something soon, the cost of mitigation is going to keep going up. That's fairly obvious, because the warming will continue, then to bring it back is going to get harder and harder. And it also turns out that the damages will, of course, increase, and the irreversibility of many changes will also become part of the game. So you cannot really control things. This is again looking at the reduction in consumption required. This is in terms of percentage points and so on. Percentage point reduction in annualized consumption growth rate over 21st century in terms of percentage points. And depending on the amount of carbon you want to allow to be emitted, the reduction will be different. So if you allow for high carbon, you don't have to worry so much about reduction. But if you want to have very low carbon, obviously you will have to have huge reduction in consumption. You can start with the low thresholds in the 2030s, which will give you the target much better chance of hitting the target. But if you wait till 2100, then you're going to require to reduce your consumption patterns against the baseline by almost as high as 84%. Right? How many of you can think of reducing consumption? What do you think is excess consumption in your life? You have to think. Amit is always riding his bicycle, for example, without helmet in traffic. So I don't know whether he's increasing his risk or reducing his risk, but I don't know how he's going to tell your sons to wear helmets when you are going around without wearing helmet. Right? People have done calculations. There are things called wedge approach and so on. You can basically look at water, energy, and food, right? Food waste is huge in the whole world, and especially shamefully even in a country like India, right? The amount of food we now consume outside of the home has gone up, right? Which means necessarily the restaurants waste more food than you would at home. Okay, so all those things are linked. With improved standard of living, eating out increases, and with that, the waste increases, plus calories increase. You tend to eat out more meat, more fish, and so on and so forth. So these are the cascades that have to be accounted for when you do these sorts of calculations. They also have to worry about what are the co-benefits. So if you say forestation is good for carbon reduction, what are the other co-benefits? Obviously, there will be, it's aesthetically better, it's better for health, air quality gets better, you get food, medicine, fiber, etc. from forests and so on and so forth. So the reduction in black carbon with stringent climate policy will give you much lower, it will give you reduced climate change. And air pollution, as we talked about before, is a big part of the human activities. So black carbon reduction has huge impact on reducing mortality, reducing morbidity, labor loss, etc., etc. And with sulfur dioxide also you have decreased pollution, and with stringent climate policy, you can actually make huge reduction compared to the 2005 baseline. I'll give you some examples of how these things work when we come to what car companies are doing, for example, and so on. They also have to worry about the factors that constrain the implementation of adaptation and mitigation. As I said, for example, California is much better at adopting new measures. They say we will not emit too much carbon. We will drive fuel-efficient cars, right? In California, if you want to go there and live there, even if you drive your old car, it will be immediately tested. If it doesn't meet standards, you will be given some time. If you don't do that, either change the car or change your fuel efficiency, you're going to be fined and you have to get rid of the car. And if you are living in, there is also a self-selection, right? In India, I don't know if it happens or not. If you move to a certain place, you expect that you are going to live according to those rules. So people who move to New York or California are going to expect that the rules are going to be harsher or more strict. So you will probably be mentally ready to do that. Plus, if that's the job, then you have to go anyways. But if you go to Texas, then the rules are very different, very relaxed, and they don't care, right? So even if you decide on measures of adaptation and mitigation, there will be many socioeconomic and cultural factors that will be involved. So adverse externalities of population growth and urbanization, deficits of knowledge, education, human capital. So within India, Kerala always comes up as the most literate state, for example, and it shows in many of the decisions they make, not always, but sometimes. Divergences in social, cultural attitudes, values, and behaviors. We talked about the difference between US and Europe, for example. Challenges in governance and institutional arrangements. So in India, there is always a big battle between government and industries. India has lots of rules, but implementing or applying the rules is going to be very difficult because it depends on which industry is involved. If you are trying to apply some standards to a chemical industry, then you know that some chemical industry people are very powerful and so on. Lack of access to national, international climate finance. So this is a big problem for many African countries and many Asian countries like Bangladesh and so on. Inadequate technology, again, problem for many countries. Insufficient quality and quantity of natural resources, big problem. If India was energy sufficient, for example, it could make many decisions on its own, but since it has to import all its energy, it cannot make whatever decisions it wants, right? Adaptation and development deficits, which are basically the capacity to adapt and so on. Inequalities, which includes gender and so on and so forth. I won't go through these, but you can read them. They are very well thought out. They give references to which sections address each of the issues in detail and so on. But here you want to just get a sense of just what is involved in making future projections, way beyond physical climate changes. This is all about social science, how we are going to deal with it. And these are examples of approaches to managing the risks of climate change through adaptation. It is about reducing vulnerability and exposure through these various categories. There are many examples included here, which range over many details, right? Food, of course, education, housing, built environments, technology options, and it also has incremental and transformational adjustments in social. Eventually, you have to decide how capable humans are of changing, and I will show what that means. So here are some examples. If you went to, I don't know, this is from the 60s or 70s probably, you could have an ad like this. It's saying, train her to be an ideal housewife, buy her a Usha sewing machine, right? This is not a secret, this was an ad in newspapers. This was not considered unusual at that time.
Even today, if you see an ad of washing machines, mom will be teaching her daughter to how to use washing machine, not to sew, which was just a year back.
So that is what this is trying to say. In 2016, it is saying, don't hold back, take your work home, right? With all the discussion about sexual harassments and so on, this guy is taking his secretary home. This is supposed to be somehow funny, right? So nonetheless, the point I would make beyond what who's teaching what is that ideally there are cultural changes happening, and ideally, so you can see this one is also from 2016. They are showing give your kid a complete makeover. So go from here to here. Why that is, you have to think about that. So human beings are capable of changing. There are norms and punishments. So most human beings can. Norms and punishments means what? There are rules and regulations, and most human beings are able to internalize the rules. And one example that works very well in most of the US would be, not in India, it would be that when there is a red light, you have to stop, right? In the US, even if you go in a small town, it's midnight, nobody is around, people will stop at the red light and wait. Here, we don't do that, but that's kind of internalizing the norm. It's not like you're going to say, nobody's watching, so I'll go through. So many people do things by remembering the rules and kind of internalizing that. So there is hope that human beings can change. But what is involved? What is difficult is that it's not just one thing. When it comes to climate change, you have to do so many things. As I said, food, water, energy is one thing, but this is a good example that shows how you get your calories from animal sources, fish or meat, and this is the additional carbon you would emit depending on which car you are driving. So if you're driving a Prius, then if you're driving a Camry, you would have more emission, and this is some other combination here. This is a SUV versus a Camry, this is your SUV versus Prius, but your total emission will depend not just on what you are driving, but also how you are getting your calories. So if you are eating a lot of red meat and you are driving a SUV, obviously you have a huge additional carbon footprint. But if you are driving an SUV and you are getting your calories from very few animal sources, then your additional carbon will be much less. Essentially, you could be driving an SUV and be a vegetarian and have less emission than somebody who is driving a hybrid car and eating a lot of fish and meat, right? And there are additional factors. People who drive Prius always drive a little bit more than they would otherwise. They think, oh, I have a hybrid car, I'm not emitting much, so they will make more use of the car. They will have more mileage than if they were driving some other car like Camry or SUV. So mentally also you begin to think, I already did one thing, that's enough. So this one action bias happens in everything. And in fact, that is kind of a danger, because if you are getting upset about, let's say there is the coastal highway being built, you don't know anything about how much coastal pollution already has happened, but you read that coastal highway is being built and this is a bad thing, so you protest, you sign a petition and you feel very good. You don't worry about, actually the coolies are eating horrible fish in the dirty waters. That should be cleaned up first. You don't even know that that's happening. So this one action bias is kind of a very dangerous thing. But human mind, there is a very nice book called The Righteous Mind by Jonathan Haidt, who is an evolutionary psychologist. And he's actually this is predates him. Basically, human mind is made up of two parts. There's a part that's called amygdala, which is like a emotional response, which is based on past experiences. There are lots of details there that I won't go into, but you can, I have written articles on this that you can read. So there is a rational rider, which is the rational thinking, and there is an emotional elephant. So some people are more emotional than others, but nonetheless, everybody has a rational part and an emotional part. When do big decisions or behavioral changes happen? It is when the rational rider and the elephant agree that this is something I want to do. And you can see the contrast. Emotional factor is usually much bigger than the rational factor. This goes into things like confirmation bias, which says that when facts contradict your beliefs, you tend to ignore facts. Okay, so you all believe something. If a fact comes along and suddenly contradicts what you believe, then you try to begin to rationalize that that's not correct. So there are decision-making studies are very, there are many of them. So rational rider is able to rationalize. It's called rational because you can rationalize, and usually it is delaying decisions. It always takes the wait and see attitude, whereas this one, once it's convinced that something is important, it will keep going in that direction, and once it moves in some direction, it's hard to steer it. So if you're emotionally decided that you're going to do something, you're going to just stick to it. Rationality is not going to prevent it. So only when both of them kind of agree that big decisions tend to happen. So this is just kind of a joke. So here is an elephant going and there are some riders coming from behind. There is a rider coming here. Instead of, those are patiently waiting. This guy, instead of waiting, he thinks he will pass on the side. Obviously, the emotional elephant is not happy, so the elephant push him into the bushes. So, politically speaking, that also means that politicians sometimes will tell you, I know your problem, I understand your problem. So they fake the emotional elephant. So this guy's created an elephant out of a buffalo, telling people that, yeah, I know what is happening. So this is important in the sense that when there is a nice book called First Rate Madness. It talks about how all big leaders in the world have been have had psychological problems. They always have mental problems, but they are still able to make big mad decisions. I think you can look around the world at a few leaders and you know there's no doubt that they are mad, right? So the point is that climate change is one thing, but actually getting human beings to act is a very complicated thing. So everything I have presented now, and this is common for all the news articles you will read, very, very few or actually nobody gives you a vision of the future. If you reduce your consumption, if you reduce your energy use and so on and so forth, what will happen? Nobody will tell you that. Will you have everything you can do? Will you have all the water, all the clean air and so on, all the food? Or is it just a disaster and you're always trying to prevent yourself from falling from the cliff or so on and so forth? So the message right now is not that clear in terms of climate change, especially for a poor farmer in India who has not contributed to climate change, but he's being told every day that disaster is coming more and more. You cannot do much and so on and so forth. Some optimistic vision of the future is needed. So for those of you young people who are thinking of doing something, you have to adopt some philosophy. Are you going to join the bandwagon and start shouting that the world is coming to an end? Or are you going to imagine that your grandchildren should be dreaming about building rockets and going to Mars and not worrying about the world coming to an end? How do you do that? How do you do that without destroying the planet? That's not an easy thing. And for the elephant, the destination has to be obvious and the path has to be clear. So a very nice book called Switch by Dan and Chip Heath, which is also a very good book to read. So for those who want to just catch up on various human psychologies that will play into climate issues, Switch is one, The Righteous Mind is one, and I mentioned another one which you can read. Many, many good books. So along with this, you have this whole economic growth idea, right? So Germany is one of the most progressive countries on the planet when it comes to climate change. They are having renewable energy. They are still burning coal, but that's because they have no much choice. And Angela Merkel is always pushing everybody to do the right thing. Volkswagen, which is a good old German engineering company, was caught cheating on its emissions a few years ago. I forgot, maybe in they did that from 2011 through 2014 or so, I think. So they got fined, Volkswagen fined 1 billion euros by German prosecutors for emission cheating. So despite having good intentions, when profit motives are involved, we are going to do shady things, right? Then there was a study done at MIT which showed that the Volkswagen's excess emissions actually led to some premature deaths in Europe. Obviously, countries hardest hit are Poland, France, Czech Republic, and Germany, right? So this is another story. There are similar stories about Obama. Angela is very worried about climate change. Obama was very worried about climate change, but Obama increased coal export because he has to somehow deal with economy, right? As a president, it's nice to talk about climate change, but you also have to build the country. So you can you can export emissions. In other words, things get complicated when different factors are involved. Germany to miss climate targets, disastrously leaked government paper. Japan again embraces coal power. This is an interesting story. Japan has been relying on nuclear power for a long time. Tsunami happened. There was an earthquake, there's a tsunami happened, neither of which have something to do with climate change. And that tsunami then destroyed a nuclear plant. Nobody knows exactly how many died, but numbers range from a few thousand to 1 million. Suddenly, Japan decided that nuclear is very dangerous. The first agreement made for climate change was Kyoto Protocol. Came out of Japan, right? So Japan decided that nuclear is dangerous, so we're going to go back to burning coal. Can you blame them? Of course not. It's a small country. Nuclear is a good option for them, but if something goes wrong, then suddenly you are going to say, forget climate change, we're going to burn coal.
Because they have had radioactive past.
Yeah. It's not just emotional, it's also very practical, right? Yeah. So the real story of US coal, Obama pledged to cut carbon emissions, etc., etc. And the world continues to burn more and more coal, okay? 105.5% change in global consumption since 1980. So more than 100% increase. So this is the statistical review of the world energy. We have looked at this kind of thing before. So you can see where coal is being burned: Asia, Pacific, Africa, Middle East, and so on and so forth. And you can put that into the mitigation, adaptation kind of situations now, and you can look for where things are already happening and what are the various sectors. So you have agriculture, biodiversity, coasts, and water resource management. You have some objective and some option, but you have to have trade-offs. So if you want to do agriculture, enhanced drought and pest resistance, and enhanced yields, that would be the goal of your adaptation. Your option would be to use biotechnology and modified crops. But people will say, India is having a lot of difficulty with GMOs, right? There are strikes against GMOs, there are strikes for GMOs, and the companies making GMOs are very friendly. They say you cannot own the seeds, we own the seeds, so you cannot save seeds for the next year, and so on and so forth. So each one comes with trade-offs, okay? And they are real or perceived trade-offs. You can always go and create a problem. If GMO is good for you, and somebody comes along and starts spreading some misinformation that actually it's not good for you, then actually you will either do the homework and learn whether it's true or not, or you will just believe depending on who the messenger is. If Anna Hazare comes to your village and says GMO is not good for you, are you going to believe him or not believe him? So some people have credibility which they can use to give you information which you will just receive as real. Okay, so these are also some things that you have to worry about. Just to make a few additional points before I move a little bit into the population thing. These are the sectors which are emitting major amounts of CO2 and non-CO2 greenhouse gases. This is important to know because if there is a lot of emission coming from transport and buildings, you know how to reduce them, right? You do more public transportation, you do more energy efficient vehicles, you do electric vehicles. If it's buildings, you make them greener, you reduce energy usage, you make green tops, you do vertical agriculture, you can do all sorts of things to reduce emissions from buildings. Industries will be much more difficult, you have to regulate them. Electricity production, again, not so easy, depends on what options you have. These are agricultural, forest and other land use, and these are the methane, N2O type of emissions. These are the number of models, did all the scenarios and so on and so forth. So this is again looking at the various scenarios and the amount of direct emissions you would get from them. One of them, these are complicated, so I'm just showing them, not going into details, because just to explain what was done takes forever, and you don't really need to know that. Other than that, these things are being considered, and it's important to consider them, because just total CO2 is not going to give you a full range of options. You have to know where CO2 is coming from to make proper action, right? So that's why it's important, but the message also will come through that if you want to meet this target, then essentially you will have to start going into negative emissions. So here it's direct emissions, gigatons carbon per year, and the numbers are negative here. So some of these scenarios cannot be met unless you begin to have negative emission technologies. This is a big discussion already, there is research being done, and of course this also includes things like what is called CCS. Everybody knows what CCS is, I think. What is CCS? Right? Either carbon capture and storage or carbon capture and sequestration. Many efforts are going on. You can read about it, but it's not yet scalable. Nonetheless, you can look at examples of sectoral mitigation measures. Renewables, obviously wind, solar, bioenergy, geothermal, hydro, etc. Fuel switching to low carbon fuels. Building integrated fuel switching to low carbon, process emission reductions, including CCS, and so on and so forth. So you have to have all these prepared and summarized properly for policymakers, right? So energy transition is a huge research area. How do societies actually do energy transitions? There are big examples from before World War II to after World War II, but right now changing from existing wired-in electricity to solar and wind, it's not that easy, especially because solar and wind are not, they are intermittent energy sources. They are not available all the time. So you have to have an option to switch back and forth. And it turns out that in the US, they boldly created a plan where you could collect your own solar and wind, and you can, when you don't use it, you could put it back on the grid. So the utility company would have to take it and reduce your bill. Soon the energy return to the grid became so large that the utility company said, stop, we cannot afford this anymore, because they also have to make money, right? So as long as you have this capitalism, profit-making businesses, you cannot boldly do whatever you think is good for the planet. The planet is nice and well, but if you cannot make profit, then what good is the planet, right? So this is the energy supplies. These are the effects on additional objectives and concerns, which include economic, social, and environmental. So you have to match all three. Whatever is good for environmental factors is not necessarily good for social, not necessarily, definitely not good for economic on many times. So these are not easy. So that's for energy. This is for transport, and so on and so forth. This is just another phase diagram that is thinking about how cooperation and global governance will happen. This is much more complicated than it looks, but essentially there are tools like emission trading systems, major economies forum on energy and climate, and so on. So it is basically looking at whether you are going to cooperate over the means of accomplishing your goals or over the ends. In other words, are you going to aim for emission level at 2100 and then force all the rules to meet that goal? Or you are going to say, we don't know where we are going, but right now we can do some emission trading locally. So states are doing this in the US. For example, if Indian region decided that India, Nepal, Bangladesh, and Pakistan will and Sri Lanka will cooperate to trade emissions, which means if you emit more, I will give you credit, and next time when you emit more, you can give me back the credits and so on. So you decide a cap together and you try to stay within the cap, and you see where it goes, right? So that kind of gives you a decentralized authority. But if you want to do cooperation over the ends, then you will need something like the UNFCCC objective, where the authority becomes much more centralized, and you will include things like Green Climate Fund, which is already not working. There are many GHG regulations that are not working. Kyoto obviously is finished, and it was generally, you would think this was a complete failure. So Kyoto Protocol was kind of centralized authority. They got together, they decided Annex 1, Annex 2 countries and so on, they made rules, nobody followed them and so on. So in the new negotiations in Paris, they created more democratic system, and they created what are called INDCs, which are what? Anybody know? These are integrated, nationally determined contributions. I think now it is just called NDC. So each country decided by itself to say how much emission reduction they will do. So each country submitted a plan saying by 2030 we'll reduce our emission GDP, or reduce our carbon intensity of GDP by 30% with respect to 2005, and so on and so forth. And then they gave various combinations of things like reduction in agricultural emissions, forestation, renewable energy, air conditioning use, transportation use, and so on and so forth. This happened in 2015 or 16. I think the first verifications will start soon. Maybe they had already started. And it is already clear that nobody is on target to meet their commitments. So democracy is nice, but in this case, there is no incentive, there is no punishment in the system. Everybody is voluntarily saying they want to reduce emissions, which is a good thing. It's not like nobody is trying. I mean, some countries are not. So typically Australia, Canada, Russia, and US are not doing much. They don't seem to care, but almost everybody else is doing something. China and India are doing a lot. Renewables and forestation, which we discussed that India's greening is not coming so much from forests, but still India has planted lots of trees. So we are not on target. Then the goal is how do you, the question is how do you get there? So pledge and review, the Copenhagen and Cancun pledges. Will it work? As I said, this is not working, and so on and so forth. So the good news is every country is involved in the negotiation, every single country, other than maybe North Korea. I don't know if North Korea is involved or not. You can look it up. Probably they are also involved. And there are lots of actions. So these are the actions in Africa, Europe, Asia, Australia, and so on and so forth. So there are various adaptation and mitigation actions going on. And the very good news is that there is money to be made, right? If you improve the solar cell efficiency by from 20% to 40% or 50%, it is going to be making you a lot of money. And the co-benefit is that it's going to reduce carbon emissions. So this kind of thing, and fuel efficiency, the American companies were not bothering so much about it, but after the 2008 financial crisis and the collapse of some auto industries, I think somebody disappeared, right? Is Chrysler disappeared? Or at least there was a big bailout required and so on. But the Japanese companies did fine. Camry, Honda, and Toyota, Honda, and Nissan, they did fine because they had fuel-efficient technologies, hybrid cars, and so on and so on. So there is money to be made. Green economy is a serious thing. Lots of money to be made, and so on. People are also considering policy instruments for each sector. Again, making policies is one thing, but implementing them is another thing, even within a country, let alone across countries. But there are various ways to do it. If you look at the way you can use sanctions to accomplish various things or not accomplish various things, the global community can come together and impose international standards. For example, child labor. I don't know if it has disappeared, but once awareness became high and people stopped buying things produced with child labor, then child labor slowly got reduced, even if it has not disappeared, because there are other social factors involved and so on and so forth. So there are various policy instruments that are available, regulatory approaches, information programs, and so on and so forth. So I want to come back a little bit and relate the carbon emissions to population and where we are headed in terms of who's emitting what and how we would actually do these, how we would accomplish the ends with or without global cooperation. We looked at this earlier. So a lot of emissions come from the United States. This is the cumulative emissions from 1850 to 2011. Historically, Europe and US together have been responsible for what's in the system. But as I said, it was decided that before we didn't know that this was a problem. So let's just use 1990 as a baseline and see from 1990 onwards who's emitting what, right? So cumulatively speaking, then China and India are very tiny, and Russia is somewhere there, and so on and so forth. So if you look at the recent one since 1990, United States is here, China is here, European Union is here, and India is somewhere here, right? Or this one. So this can be used as background on which you make all your negotiations. But it's still more complicated. If you look at per capita emissions for top 10 emitters, right? So here is Canada, which is disproportionately high carbon emissions, United States, Russia, Japan, and so on, and India is here. Is this good news? Not necessarily.
Population, so multiply.
Yes, so that is where I'm going with population. Population of India is 3 times the US, let's say. And you look at the emission, will you get that if you multiply by population? Right? So it's still, so we have to be careful. We always jump, as I said, we carry these things in our head, and it's not always factual. right? So just say India is very crowded, so even if it is low, it must be higher than US. Actually, it's not. But the worst news is if average per capita emission in India is 2 tons per person per year, this is the average, right? How much Ambani is emitting? Probably in this range, right? Or in anybody. So the economic development comes with standard of living. So all of us are probably emitting at some European level. But there are very, very poor people which are emitting very little, right? So the averages don't mean anything, especially because if India is really growing at 7% per year in economy, by 2030 our emission will be here, then population will definitely be a problem overall. But there are additional factors as well. The population fertility rates have been dropping for 30 years. So you can already imagine that more and more women don't want to have more than 1 or 2 kids. And in the rich countries, evolutionarily, people would expect that if a woman is rich and educated, she will probably have more kids because she has more resources. Obviously, it didn't turn out that way, and they had to do research to figure out why rich women don't have more kids. And it turns out it's something like an allometric scaling where they want to give as many resources as possible to each kid. So having fewer kids helps, right? Problem is, a woman with 2 kids emitting at 16, 18, 20 tons per year is actually much worse than a woman who is having 4 kids and emitting 2 tons per year. So having fewer kids doesn't necessarily solve the problem unless you can bring down the emissions and consumption. So population in that sense is somewhat of a fake problem because population is decreasing anyways. Educate women and population goes down. This has worked very well all through. But decreasing population is not coming with decreasing emissions because consumption keeps going up. So that's a big, big contradiction there. The other details like this, if you look at the age structure of developed countries in 95 versus 2025, very few young people, aging population. So this has become a huge problem in Italy, Portugal, Greece, Germany, and so on and so forth, where they don't have enough working people to support the retired people and so on and so forth. Many of them are below replacement already. Replacement population, each couple has to have 2.1 kids. Many of them are having much less. So there are even incentives in France and so on to have more kids, which sounds funny. And even China now removed the one-child policy because they have created a massive problem by having that one-child policy. There are many old people dying on their own and not having enough young people. But if you look at developing nations, we have this structure where there are huge number of young people, right? So this has worked to our benefit in many ways because all the outsourcing business, of course, plus this also means that you have a better opportunity to educate the girls and obviously reduce population. Doesn't mean you will reduce consumption, but nonetheless, if you look at the percentage of girls enrolled in secondary school.
What is a healthy graph? What will be in the shape of a healthy graph?
Well, basically you have to have enough young people, so it shouldn't be this distorted. It should be broader and narrower, but not necessarily this much. Because in India, the big number is that 25% is below 25 or whatever, some such number exists. Which means what? All of them need jobs. What is the unemployment rate in India? It's probably 20% or more, probably, right? In some places it may be even higher, right? So there are disadvantages and advantages to having this. A lot of cheap labor, right? You go anywhere in a restaurant, each table will have 3 waiters, each mall will have 4 people following you to sell you something, and so on and so forth. But those are not jobs which are high quality, they are not well paid and so on. So quality of living goes down, especially in urban centers. All those working people, they cannot afford to live here really, right? So they live in very poor conditions. So you need to have enough young people to work to support the aging population, because people now live longer and longer. Lifespan has gone up tremendously. So even though we are the diabetes capital of the world and so on and so forth, everybody lives to 87, 88, right? Nobody dies anymore. So this is the percentage of girls enrolled in secondary school. As the number of girls enrolled increases, total fertility rate drops. This is a very solid relation which is independent of religion and so on. So this is education is the best contraception. That works very well, okay? So fertility rates in 1970 and 2014, you can see that we were at, what is this number, 5, 6 children, and we are now down to 2, 3 children. So only few hotspots remain, like Niger and I don't know, some African countries. Pretty much everywhere else, one neighbor here, but pretty much everywhere else, the numbers have dropped tremendously. So population, is it really a problem? Of course, it's still growing because the baseline is, we started with is very high, but fertility rates are dropping. So there are some projections that by 2050, we could be in negative population growth, and by 2100, we could be down to 1 or 2 billion. But these are very uncertain projections. We have to be careful. So what do? You want to have, this is a nice graph that shows ecological footprint per person, and this is the Human Development Index, or HDI, which takes into account per capita income, women's education, children's health, access to water, etc., etc., etc. And it is not surprising that all the countries that have very low ecological footprint also have very low Human Development Index. And all the countries that are doing very well in terms of HDI also have a very high ecological footprint, right? So you want the whole world to become better, to have better standard of living and so on. And the question is, can you move the HDI this way without increasing ecological footprint, or do you always go this way, that to have a better life, you have to increase your ecological footprint? So this can just kind of summarize what the goal is. You want everybody on the planet to have a high HDI, but you also want everybody to be in this global sustainable development quadrant where the ecological footprint is low. Nobody's well, I think that's the question. So who will get there, or whether we are capable of getting there. So there are many global programs now called Future Earth and so on and so forth, and the goal is to get there. So the question is whether that comes as a game changer, that there will be some huge invention that will suddenly start taking carbon out of the air and suddenly we will have no global warming problem, or whether it will be some incremental thing, right? Everybody probably heard of the word phrase game changer. There is a figure you can find probably by Googling. Telegraph is considered one big game changer, for example. If you go back to telegraph, everything it has led to in terms of inventions that depended on it goes all the way to smartphones, space travel, internet, and so on. So this remote communication first step has been responsible for basically all the big communication changes and space travel since then. So game changers may come along. You think smartphone is a game changer, but actually it's not. It's just an incremental change on the telegraph, and then what happened after that. So game changer is something that will, maybe game changer is that everybody is now texting all the time. So you don't, even at dinner, you will not be talking to each other. I went to the temple once to meet a priest, and he was standing there like this. I thought, wow, he's praying, but actually... So what does the future hold? The future of food scientists may have to find fast. Last night at dinner, there was some discussion about lab-grown meat. There is plant-based meat now, and so on and so forth. But there are also some interesting experiments going on. So this is the mosquito town where they released some genetically modified mosquitoes. 4 million mosquitoes carrying Wolbachia bacteria were deployed across Townsville in Australia. The graph below shows insects taking root in the central suburban Belgian garden. So the mosquitoes release over this period, and then they tracked, after the mosquito release, locally acquired dengues plummeted. So as these bacteria-infected mosquito population reached its peak, the dengue infection dropped off. Okay, so the coverage in area by the bacteria-infected mosquitoes took hold. So is this a Frankenstein experiment or is this a future? Who knows? Maybe suddenly they will discover that these mosquitoes are creating some other new disease that we didn't know about. So scientists, they created an embryo of an extinct rhino, and they hope to revive it. So this is like Jurassic Park. So you can keep on collecting interesting stories. This is useful because this is more about solutions. You can find plenty of articles that tell you every day what is going wrong, right? Climate change stories are now in every newspaper every day, and it's always bad news. But there are also one or two good news here and there that you can start collecting. So I will show you one good news for a couple of minutes, and then we'll decide what to do after this. Going to work? Yeah.
Solar freaking roadways.
What are they?
They're solar freaking roadways. What do they want from me? Well, they're solar freaking roadways. Okay, so actually this time, what is it? It's technology that replaces all roadways, parking lots, sidewalks, driveways, tarmacs, bike paths, and outdoor recreation services with solar panels. And not just lifeless, boring solar panels. Smart, microprocessing, interlocking, hexagonal solar units. No more useless asphalt and concrete just sitting there baking in the sun, needing to be repaved and filling with potholes that ruin your axle alignment on your sweet ride, bro. These are intelligent solar panels. Replace the panel at a time if damaged or malfunctioning. They're covered with a new tempered glass material that has been designed and tested to meet all impact, load, and traction requirements. Oh, and did I mention that they're also solar panels? They generate electricity. They generate capital. They pay for themselves. They keep paying more because we're not going to run out of sun for like 15 billion years. That lowers the cost of energy, unlike those bills in the mail that keep going up. And it's clean energy. Everyone can theoretically drive an electric car with no pollution and a minimal carbon footprint. Can you imagine how good our cities would smell? How much healthier we'd all be? Excuse me, young man. Am I being led to believe that this thing is some sort of thing? Yes, it's a thing. A real thing. And clean energy is only its primary function. Grab a notepad because this is where it gets interesting. For those in the north, the panels use energy they collect to power elements to keep the surface temperature a few degrees above freezing. They're heated. No more ice and snow on roads causing traffic delays, accidents, and injury. No more shoveling your driveway and sidewalk. No salt corroding your car or wasting tax money on snow removal. And you can ride your bike or drive your motorcycle all year round. Whoa. Every panel has a series of LED lights on the circuit board that can be programmed to make landscape designs, warning signs, parking lot configurations, whatever. These roads never have to have lanes repainted, just reprogrammed to whatever we choose or whatever works best. Imagine a highway road lighting up ahead of you. How much safer it would be to drive at night. There'd be improved visibility for pilots landing on solar landing strips. Imagine walking onto a solar recreation court and choosing a sports configuration. Want to play basketball? Cool. Kids want to play hopscotch and foursquare? Awesome. Ball hockey? Done. And with LED lights under your feet, it's gonna look like freaking Tron out there. But real, because this is the real world. Whoa. But these panels are also pressure sensitive, so they can detect when large debris like branches or boulders have fallen onto the road, or if an animal is crossing. It can warn drivers with LED text to slow down for an obstruction.
I'm very, environmentally conscious.
Good, because solar roadways use as much recycled material in their production as possible. Plus, the roadways have two channels that form what's called a cable corridor that runs concurrently with the roadways themselves. One part houses electrical cables, meaning power lines, data lines, fiber optics, and high-speed internet, which replaces the need for telephone poles and hanging wires that can be damaged during storms, causing power outages, or become extremely dangerous if severed either as fallen live wires or buried cables. The other channel captures and filters storm water and melted snow, moving them either to a treatment facility or treating them on-site, greatly decreasing the amount of pollution that enters our soil, lakes, rivers, and oceans. I'm kind of broke, bro. Yeah, no kidding. The economy is in the toilet. Do you realize how many thousands of jobs this could create and sustain? Talk about a hypodermic adrenaline shot to the heart of the manufacturing and infrastructure sector. And it pays for itself. They're solar freaking roadways. I have concerns about the future. Is this thing even possible? I told you, yes. Solar roadway technology was in.
I don't know. So, if human beings are smart, maybe they'll find solutions to all these problems. Probably should wrap it up. This is the socioeconomic pathways that are now being designed to convert these physical climate change into various socioeconomic pathways. So we have RCPs, then we're going to have SSPs to follow up. Then there are also ocean shared pathways, and this is just some history. And I think we can close. This is the part of the course, and I think we have some ideas of discussing monsoons. We can start after 5 minutes and then maybe wrap it up tomorrow during regular time. Is that the plan? Okay, good. See you in a few minutes.